Dun, 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 dun. Good morning, ladies and gentlemen. Howdy, hello. I hope this finds you well. Alright, we have some good things to go through today, some good stuff to accomplish. I'll give a minute or two for people to arrive, and then we will get started. Let's see. Let's make sure this is looking good. I can still zoom this in some more. That froze. There we go. Unfrozen. And a little zoom. Zoom, 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 zoom. Okay. Okay. Alright, don't want to waste too much time here at 9:15. Some important things to talk about if you're coming back and watching this later. Our class will be making a bit of a transition into Google Classroom. I feel like, not into Google Classroom, into Khan Academy. It just provides me a better way as a teacher to keep track of where you guys are, to give you more consistent materials, to give you more practice, to give you better practice, to give you better feedback. There's a bunch of reasons why it's going to be how we're kind of moving forward. And I mean, I started it with my algebra kids, and they seem to be really enjoying it. And I'm not going to say preferring it, but enjoying it, and enjoying the freedom of not having to sit here every morning at 8:15 or 9:15, depending on what class you're in. So with all that mentioned, with all that said, expect a nice post. After this stream ends, I'm going to do a nice big post about it, but I still thought it'd be worth giving one lesson here before we kind of change what we're doing. So I'm glad you're all with me. Hopefully you printed this out or finding a copy or something from the Google Classroom. All right. Again, if you need any information, if you need any help, if you need anything, make sure you email me, or make sure that you go to the Google Classroom and leave a comment so I can go back and make sure that everything's doing fine. One thing to type here. Excuse me. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so we are going to get started here, ladies and gentlemen. So let us do it. Okay, that hasn't changed. That hasn't changed. So, and some of you actually probably already got an email in your inbox about the Khan Academy because I started setting it up this morning. But before we get too far into that, let us begin. You got to do some adjustments here. It's been a couple days since I did this. Not a couple days. It's been 2 days. All right. Too short. Stand this up a little bit. Hey, there we are. Okay, so, ladies and gentlemen, boys and girls, let's talk about this. Today we are talking about tangents. Remember that tangents are lines that just barely touch the circle. And when I say just barely, I'm saying that this line only touches this circle at this one point. Remember, if you keep zooming in and zooming in and zooming in on a circle, it will always still be a curve. And so at the smallest, at the biggest zoom that we could possibly do, we would still have a curve. But it would be curved in such a way, and in an obvious-ish way. Let me grab there we go. That we can draw a line that literally grazes past it or barely touches it at one point. Okay? And that's the idea behind a tangent. And so what we'll find out that happens with tangents is that they have some special properties and special applications to different situations. So let's go and do that. All right? Dun, dun, dun. This first section, if you join me on it, it's just, again, reviewing this vocab. With all of these circle lessons, one of the most important things has just been the ability to identify when each of these things are happening, because we learned rules about secants, we learned rules about chords, we learned about diameters, radii, we're learning about tangents today. So knowing which piece is what and where each piece is really important in the grand scheme of things, so you know what tool to use in each situation. So with that said, let's get started. Looking at point D, What is point D? Well, point D is a point of tangency. It's a point where a line barely touches the circle. And we see that happening at H, we see that happening at F, we see that happening in E. All of these are points of tangency because it's a line that just barely grazes our circle. And what you see in each one of those 4 places that I highlighted, right angles. So because this just barely touches the circle, what ends up happening is that the radius is perpendicular or makes a 90-degree angle with that tangent. So the radius or diameter and tangent will always intersect perpendicular or with a 90-degree angle. So now with this in mind, we can do things like solve for missing lengths using Pythagorean theorem and right triangles, things like that. But that's a little ways down the road for us. That's on the back side of the sheet. Let's work through the front side. First up, it wants to know what FH is. And this is one of those vocab words that some students were struggling with when we did the vocab on 11.1. Real quick, I'm going to draw a little dashed line between these two because this dashed line is going to let us know, am I dealing with an external or an internal tangent? An internal tangent will always cross through this imaginary line, and this imaginary line just connected these 2 circles. An external tangent does not cross, this one's the external tangent, does not cross over this invisible line between the 2 centers. So what we have here with FH, notice the double arrow on the top, so it means this infinite line, FH, is a internal tangent because it's inside or it crosses through that imaginary line. Next up, CD, notice this is just line CD. So it starts here and ends here. It doesn't go any further than that. That would be a radius. AB, notice again, AB has endpoints. So it's just talking about this A to this B and nothing else because the symbol on top says it has endpoints. So this is a chord, right? It has endpoints on the circumference or perimeter of the circle. It seems that my stream quality right now is low, and I greatly apologize for that. There's not a whole lot that I can do to affect that. That's more of a neighborhood issue, ISP issue, not necessarily my issue, but I do apologize for it. So, hold on, I got 2 things to grab here. I want this. I want this. Yeah, okay, cool. So, next up, we have C, which is just the center of a circle. We have AD with endpoints, top to bottom here. This goes across the whole circle. It cuts it in half. It goes from end to end through the middle. That means it has to be a diameter. AB, now going infinitely in both directions. This whole thing here is what we call a secant. Secant in chords, the only difference is that a chord stops and a secant does not. So that's how AB here, when it had endpoints, was a chord, but when it never stops, it is a secant. Then with DE, as we already talked about, this is an external tangent because it barely touches these circles at one point and does not cross through our imaginary line between the 2 centers. External tangent it is. All right. So, again, just to review some of our vocab, and especially the point of tangency, common internal and external tangent, because that is what we'll be talking about today. Tangents, tangents, tangents. So, these first few questions are a little silly, little simple. All right. What is the relationship between diameter and radius? And we'll see kind of where this comes into play because, as I said, with these right angles that we're using radii, and we're going to be using right angles and right triangles with them. So it's important to know how to calculate the radius, calculate the diameter, and go between the two. And that's why we have this short little exercise. We know that the diameter is equal to 2 times the radius. So if we want to know what this radius is, we can just divide the diameter by 2. And so then we know that our radius is our diameter divided by 2. And we're going to use that, and then in the next section we'll use this blue one to kind of go back and forth. So take our diameter divided by 2 for our radius. So our radius is 13 divided by 2. If you want to plug it into a calculator, you can, but we get 6.5 inches. Same thing here with this diameter. Take this diameter and divide it by 2. 8 divided by 2, 4 centimeters. I know, kind of silly simple, isn't it? All right, same thing here. Diameter divided by 2 is equal to the radius, is equal to 12.6 divided by 2. And if you needed to plug that into a calculator here, 12.6 divided by 2, get 6.3. All right, then also this one, worded a little bit differently, right? We have feet and inches. There's two ways we can do this. One, we can convert it into inches entirely and then solve for it. We'll do that one on the left side. And then on the right side, I'll show you a different way of doing this kind of problem. On the left side, actually I'll do the left side. I'll divide my feet in half. So that becomes 1 foot. I'll divide my inches in half. 5 divided by 2 is 2.5 inches. And that's a totally acceptable answer because it works like that. Or as I said, we can convert it 2 feet to inches. How many feet are in an inch? How many inches are in a foot? 12. All right. So 12 inches and 12 inches for 2 feet make 24 inches. So then we can take the 2 feet, we can add 5 inches for this 5 inches. And now divide that 29 by 2 to get our answer here at 14.5 inches. And these are equal or the same. Just two different ways of thinking through these couple problems. Let me scoot that over so you can actually see it. I know I moved through those pretty fast, but it's really multiply by 2, divide by 2, radius or diameter. Radius is short, diameter is long. All right, let's move this a little bit so I can scoot this up for our final little piece here. Same idea. Radius is given, find the diameter. Take that radius and multiply by 2. So in each of these cases, I can take my radius and multiply by 2. Whoa. This pen was leaky. Ew. Ew. 2 times 17 is equal to my diameter, so my diameter is 34 centimeters. 2 times my radius equals to my diameter, so 2 times 6.3, or 12.6. Right, and we can just continue this idea, keep working through these problems the same exact way. 2 times the radius is equal to the diameter, so 2 times 0.75 equals our diameter, and when I plug that into a calculator, or if you're good with these in your head, you can also calculate it there. 0.75 times 2 for a cool 1.5. As I kind of said, today's lesson is a little light, is a little simpler, but it's an important stepping stone to kind of getting where we're going. And again, 2 times the radius equals the diameter. So 2 times 4.25 equals our diameter. 2 times 4.25, again, our handy dandy calculator to help us. 8.5. All right. Okay. So that's literally, that's literally the idea. There's not a whole lot beyond this when we're talking about radius, diameter, and talking about the pieces, the vocab words. So let's move on to the back and really talk about some tangents. On the back here, or on the second page, it says, what is the center and radius of this circle? What is the center and radius of this circle? Notice, we just changed. Everything we did up to this point was just abstract pictures like these ones where you just have a circle somewhere in the universe. Now all of a sudden we have a circle and we have a grid. So that grid allows us to do different types of calculations, manipulate it differently, and see these things differently. So we're going to spend a minute with this picture, all right? First it asks for the center and radius of circle A. So the center, this is just a coordinate plane, x and y, so we can use an ordered pair to find the center. 1, 2, 3, 4 on the x, and 1, 2 on the y. Then the radius of A, again the radius goes from the middle to any side. So from the middle to any side, I mean, that's 2, that's 2, that's 2, that's 2. my radius is equal to 2. And we can do the same idea, the same thing with this circle B, where it says the center and radius again. So we're at 1, 2, 3, 4 for my center for B. And then 1, 2, 3, 4, 5, and 6 for my center on my Y. And then the radius again, from the middle to any side, it's all equal because it's a circle. To this side, this side, this side, this side. Doesn't matter, it's a circle. And that's what a radius is. A radius is from the middle to the side, and that distance is always the same, or else it wouldn't be called the center. All right. Describe the intersection of these two circles. So, right, as I said, if we want to know what's going on, we could zoom further and further and further and further in. But, we can only zoom so far. Our eyes can only go so far. So let's bring it back. Hold on, let me make sure I didn't lose you. Okay, cool. So, what's happening at this intersection is that they touch at exactly this point. Do they touch anywhere else? Even though the black line makes it kind of look like it, this intersection is one single point. So there is one point of intersection. And that is at 1, 2, 3, 4. 1, 2, 3, 4. And so the next one is actually a question I really like. Name all the common tangents, or describe them, for these two circles. And actually what I'm going to do is draw them. We have to think, a common tangent means it's a tangent for circle A and a tangent for circle B. So it's only going to touch A or B, or A and B at one point. Look at this pink crap I got on my fingers from that nasty pen. All right. So, right, we have to kind of work around this picture and find points where they only touches each circle once. Well, we said that these two circles only touch at 4, 4. So, that's a tangent that touches both circles and only touches them at one point. Try to think of another common tangent between the two circles. It's really hard to wake up today. I keep staying up later and later, which is very much unlike me. All right, so you took a moment to think about it. I'm thinking here, if it goes down this circle just barely touches x equals 2. And so with the same idea, it barely will touch at x equals 6. And now we've found all of our tangents, all of our common tangents. All right? And so our final question, are the two circles congruent? Remember that congruent means the same size and shape. So you have to ask yourself, does this have the same area? Does this have the same perimeter? Does it look the same? Is it in a similar orientation to this circle? And I would definitely say yes. Why would I say yes? Well, they have equal perimeter. They have equal radius. They have equal area. Because of those three things, it's impossible to have a circle with the same perimeter, radius, and area that isn't the exact same circle, just copy and paste it somewhere else on the page. Right? Somebody took circle A, copy pasted it, and renamed it, made circle B. And that's what congruent means. Again, it means like a copy and paste exactly the same. All right. And so we're going to spend a couple minutes here at the end because questions 12 and questions 13 are really kind of what we were working towards and what we really actually want to do with tangents. Everything before this is kind of conceptual, kind of to get you thinking about tangents, but what we're doing now in 12 and 13 is the actual work of the types of questions that you could expect to see on a test or quiz. So, tell whether AB is tangent to C. And actually, a great example of this is happening right here. We took this radius for circle B, and we drew it, and then we drew a tangent line. And remember what we said on the front side of the page. All tangents to a circle have to be perpendicular to a radius. So that's what it's asking down here in number 12. The only way AB, this line, could be tangent is if this is a right angle. All right, and what shape do we see getting made here with ABC? A triangle. And we have a way to check with the three sides whether or not a triangle is right, acute, or obtuse. We did this back towards the beginning, like January, February. We took a squared plus b squared and then compared it to c squared. Didn't set it equal. We just compared it to see how it compares and if it ended up being equal. All right, so let's kind of go through that process here. Remember that c squared is going to be your long side, a squared and b squared are your legs that surround the right angle. So, how does 8 squared plus 12 squared compare to 17 squared? Well, 8 squared is 64, 12 squared is 144, 17 squared is a number I don't know off the top of my head, 289. All right, so let's see how it goes. 64 plus 144, and how does that compare to 289? I think we can already tell what's going to end up happening. 64 in this make 208, 289, and these are not equal. And because they're not equal, AB is not tangent. Because if it was tangent, then it would have a right angle. And if it had a right angle, then this would be equal. And since it's not equal, it's not a tangent. All right? The same idea over here. We need this to be a right angle in order for this line to truly be a tangent. So, let's do that same process. Let's take a squared and b squared and compare them to our hypotenuse, c squared. All right, 7 squared, 24 squared, 25 squared. So, 7 squared, 49, 24 squared, 576, 25 squared, 625. All right, so let's plug all these in. 49 plus 576. And how does that compare to 625? Well, let's add them up and find out what we get. $625. When I add them up, I got 625. So what ends up happening is that these are equal. All right. And because it's equal, it's the opposite of what happened here. AB is tangent. Because AB is perpendicular to the radius. And that's what we said. A tangent, to be tangent, has to be perpendicular with the radius. And if it's perpendicular, then it's a right angle. And if it's a right angle, then it's a right triangle. And if it's a right triangle, then we use Pythagorean theorem. And that's how all of this stuff continually interrelates with each other. All right? Okay. If you do have any questions, make sure, as always, to post them on the Google Classroom. I am checking, I am looking, I am considering. All right. Give me a second here to check while y'all catch up. No comments. Okay. Don't be afraid to email me. Don't be afraid to ask me questions. I'm here all day. Basically every day. All right. Here we are on number 13, our final stop. It already tells you these are tangents. And so what this is actually taking us into is the fact that I call these ice cream cones, right? They all look like ice cream cones. A delicious scoop of ice cream. If you were in class, you know that I would be asking what your favorite flavor of ice cream is and debating whether or not it is actually the best flavor of ice cream. Because I can let you know that there are some like garbage tier ice cream flavors out there. We can all agree that there's just like ice cream that nobody should be eating. Question number 2, why don't they make grape flavored ice cream? I know they make grape flavored popsicles, but that's not what I'm talking about. I'm talking about grape flavored ice cream. Where is it? We have every other fruit. Where's the grape flavor? Think about that. Meanwhile, we have these ice cream cone problems over here where I have a point, we can call it a point of concurrency. That's all to say is that if you made 2 tangents, they'd run into each other at one point, and that point is A. And so we have to think about how these distances are related. Because, well, how can these distances be related? I'm over here. The distance from this point to the circle is this, and I know it's a tangent, so it's a very specific, perfect point. And the same idea over here. It's a very perfect, specific point. And so, if I were to spend 20 seconds here kind of proving this idea, and then we'll do some examples. 20 seconds proving this idea. I'm going to grab my practice copy and kind of draw on this one, and then we'll flip back to the other sheet. You can choose to draw this or not. I feel like it's going to make the picture a little cloudy. So, first I'm going to draw from the point of tangency to the center. I'm going to draw my 2 radius. I'm going to call this point B. I'm going to make this point D. And since it tells us they're tangents, we know this is a right angle, we know this is a right angle. We know that these 2 radius, or radii, are equal to each other, and we know they have a shared side. So all of a sudden, we're dealing with 2 right triangles that are back to back, that are going to have right angles. 2 sets of sides are going to be equal to each other. So all of a sudden, we have a hypotenuse leg proof, not even a quote-unquote proof, an actual proof of why these 2 things are going to be equal to each other. In all of these cases, I could keep drawing the same right triangles, and the same thing would keep happening. Right? Draw that. Draw my radii here and here. We would make right angles. All of a sudden, these 2 pieces would be equal, these 2 pieces would be equal, and then everything would be equal to each other. So as we go into these examples, realize that this is why we can say these 2 things are going to be equal to each other. And now that you know that, these problems get very quick and very easy, right? We said set them equal to each other because they're both tangents. 7x minus 2 equals 3x plus 8. And just do your algebra steps. Solve for x. We want to know what x is. So I'm going to move 3 over first to get all my x's together. I'm going to move my 2 over second to get 4x equals 10. And then divide by 4 on both sides. I'm running out of space, but 10 divided by 4 for my answer. And let's pop that into the calculator to see what it is. 10 divided by 4, 2.5. All right, on to the next one. These are 2 tangents on my beautiful ice cream cone here, and that means these 2 lengths have to be equal. All right, so these 2 lengths have to be equal. Give me a second here, trying to get my brain right. And let's set them equal to each other. I know you guys love solving these questions with x squareds. All right, x squareds. So let's work through. Take out 25 on both sides to get x all alone. we have x is equal to 25, and so then we can just square root, because the square root and squaring are inverse or opposite operations. So they will kind of cancel each other out. We'll just be left with x. And the square root of 25, we're saying, what is two numbers that multiply times themselves? So x times x, some number times some number equals 25. And we can plug it in if you don't know off the top of your head that 5 times 5 is definitely 5. Or 25. Ha 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 ha. Same idea over here on part C. All right, this will be our final question. 3x squared equals 12. Divide by 3. Divide by 3. And that means x squared is 12 divided by 3, or 4. And we'll do the same exact thing. Take a square root, take a square root. What number times itself is equal to 4? Well, if you're not sure, 2. 2 times 2 is 4. All right, and that is it for today, ladies and gentlemen. It was nice, it was light, it was simple. Most of the time, these first lessons, 12.1, 11.1, 9.1, are quicker lessons because they're more introductions than anything, all right? Look for a decent amount of information to come on the Google Classroom today. I'll make a nice post. Also, check your email and see if you got an email from Khan Academy to sign up. I'll be making a larger post in a little while here once I finish writing it all out. That just describes, how we're using Khan Academy, when we're using Khan Academy, yada, 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 yada. You get the idea. All right. I hope you guys have a wonderful Thursday. All right. One thing worth mentioning here at the end, don't leave. One thing worth mentioning here at the end is that tomorrow I will be holding a Google Meet. And what Google Meet is just a way for us to talk live. All right? It's a way for us to talk live. And so by talking live, how do I say this? I'll be able to answer questions, go over things, or we can just sit and talk about life. As fun as it is to talk about math, these are kind of crazy times, so it gives you a chance to talk to some of your classmates, give you a chance to talk to me, ask me questions, figure things out, ask how my dog is, ask how my wife is. I can ask how your family's doing. We can just chat, and it'll be nice. So look forward to the link to that tomorrow morning. It will be at our same meeting time, 9:15. So if you're awake and ready at 9:15 tomorrow, make sure you join that Google Meet so we can chill. I'll probably be playing guitar, just hanging out and just talking with y'all, answering math questions, answering life questions, and I hope you have a great day.